Good morning, this is Vetri. Today I am going to teach you implementation of doubly linked list using C program. So here you can see the linked list, which is a doubly linked list. So here we have two pointers. The first one is head and another one is tail. Okay, so head will have the address of first node and tail pointer will have address of the last node. And here we have the two connections. See here, this section, in the first node, next section will have address of the next node, and from the second data it have the address of the previous node, which is 100. Okay, so here I am going to keep 400. So 100, 200, 300, these are random addresses. Okay, so first of all I'd like to explain the pointers. First one is head. Head will have the address of the first node. Okay, so head will have the address of the first node, which is 100. Head will have 100. Okay, and then tail. So tail will have address of the last node. Clear? Address of the last node is 400, and the last node at tail next always will be 0. It will be 0 because it's going to be the last node, right? Now, so let me explain from the creation of node. Okay, see, so we all know that we have discussed about creating node and creating data type for the node. We have discussed already. So the procedure is struct node. So here I have three elements, three fields, one for storing previous, and second one is for data, and third one is for next. So data, I'm going to take the data as integer. Next, so we all know that how to create pointer for previous. I'm declaring struct node asterisk previous struct node next. So these are the three fields available in doubly linked list. So apart from that, here we have two more pointers, right? The pointers are head and tail, so we can declare it separately. Struct node head and tail. Okay, so almost the declaration of pointers and the fields completed. Now, so let me explain the function create. So I didn't create at the node yet. Okay, just I have created the data type for creating the node. Now, void create. So I have written the create function. First, struct node new, so which is nothing but it's a new node. It will have the address of the new node, and then initially head value will be 0. It doesn't have any address. Okay, initially we have to consider head will be 0. After that, I have to allocate memory for the new node. For that, we all knew that the syntax for allocating memory space. First I have to typecast the function struct node and malloc size of struct node, right? See, size of struct node. Now, after allocating the memory space, I have to get the data from the user. So I have to use printf, enter the data, and by using scanf I am going to store it in a memory location. So my input is going to be integer, and I am going to store in new field. So it new at the field previous next. So these two will have only the address, so I have to store in a data. So here we have declared data, so which is the structure. So always new will have data, next, previous. Okay, so from that I'm going to call new arrow mark data for storing the data, because data field will have only the data. Okay, next. So I have declared it, right? Now at this point I have, this is the sample one. For example, after allocating the memory space, so I can consider as 100. Okay, so it allocated the memory space 100 for me, and my data is going to be example 5. Okay, now so I don't have any previous data, right? So it's 0, and this is the first node. I'm entering first node, so I don't have any next node also. So at that case I have no next node. Okay, so for that I'm going to write the terminologies here, right? New previous is equal to 0, and new next is equal to 0. See, new data already I have inserted, new next will be 0 and new previous will be 0 at the initial stage. Okay, when I'm inserting the first data into the linked list, it will be 0. Okay, now so let me explain with the different cases. Okay, so here we have 3 cases. Let me explain one by one. Okay, now we have created everything, right? So let me explain now what will be the position, what will be the address of head and tail. Okay, see, new next will be 0, new previous will be 0. After that, look, the pointer, head pointer will have address of this new node, and tail I already explained what is tail node, right? Tail pointer. So tail will have address of the last node. Initially we don't have any last node because we have only one node. So tail also points to this node. Okay, now I'm going to continue. Head is equal to tail is equal to new. Okay, but so this code is okay when we have only one data, one element in the list. Okay, but in some case if I want to insert more data, see, so after making this new field, the first field as head and tail, what will happen? So I have made a head node as this one. When I'm trying to insert a new node, so initially I have written the code like this, right? Head is equal to 0. In that case it will be okay, but now head is pointing to new node. For that case I have to change, I have to apply the condition if head is equal to 0. If head is equal to 0, I can go with this, right? I can make head and tail is equal to new node, but in this case now head is pointing to the new node, right? So when I want to insert a new node, I have to change it. So here the conditions are, so now I'm going to strike out this line and I'm going to apply a new condition, so which is simple. If head is equal to 0, in that case head and tail will be new node, else, because it's not in that condition, so I have to change. So tail next is equal to new, and then now new node previous, the previous field of new node will have the tail address. Okay, then tail will become new. So I will explain you with the diagram. See, this is my newly inserted node. Okay, so it has the data 5, and so I am going to deal with these 3 field. Just simply I am going to change. In a singly linked list we have used a temporary pointer, temp pointer, for storing a new data, right, for adding a data one by one. But here I am going to use tail. Okay, so initially this is my tail. Now the tail next will point to the new node. So whatever the node, it will have address, for example 300. Okay, the tail node will have address of this new node, maybe I mean the next node which I am going to insert. Next, see, new previous is equal to tail. This is the new node, right? So maybe it will have data like 7, and the new node previous, this is previous, right? Previous will have address of the new node, right? So the address will be 100, right? Okay, and finally I have to point, because we all know that tail will have the address of the last node. So this is the last node, right? This is the first one which we have created already, and this is the recent node, the last node. So I have to change the tail node to this. Okay, so this 3 lines means that. Okay, first I have to change address, the tail address, tail next is equal to new node. I have to point to the new node, and then new previous is equal to tail, which is nothing but the new node previous will call the tail node, and finally I have to assign the new node as the tail node, because tail will have address of the last node. Clear? And so next, so I can keep the decision so if you want to continue the process again and again, so I can make the loop. See, I can use I can get the options from the user by using printf. Do you want to continue? Scanf %t. So I can give option like 0 or 1. Choice. So you can ask, we didn't declare the choice data variable, right? So in that, here I can declare it integer choice, integer choice, and where I have to put the condition. See, I have to write at this location while I don't have space, so I am writing under to it choice equal to 1. So if the user want to continue, I mean they want to insert more data, so it will, the loop will create again and again, it will allocate memory for the same. Okay, now so that's it. After that, for every insertion they have to change the pointers, right? And now we have 2 cases, right? The cases, do you want to insert at location? We have 2 cases. There are many cases, like I want to insert at beginning of the list, I want to insert at end of the list, I want to insert at particular position, I want to insert before to the particular position or after to the particular position. So these are the different cases. So I am going to teach you 2 methods when we trying to insert at beginning of the list and when we trying to insert end of the list. Okay, by using simple strategy. See, the creation concept is completely same. Okay, so we don't want to disturb this. So let me explain with the diagram. Okay, using the same logic, see, here I have the diagram. Look, so this is the first node. So I want to insert a new node at here, at the beginning of the list. Okay, now see, so what are the pointers I need to change? First I have to first see here, this is the head, right? So before I want to insert, initially the previous of the head node will be 0 because I don't have any node at previously, right? So here I'm going to insert this node in front of this. So this will have address of this node, right? So for example, by using numeric allocation, so just consider it is stored in a address of 50. Okay, so this one will have it will be changed to 50, and then have to make this node as a head one, right? Because head node will have address of the first node. For that principle, so I have to change the head node to the new. So I have to change the pointer, head pointer, to the new node, right? So these are the two swapping I have to done. Okay, see here the methods are: first I have to change head previous is equal to new. Okay, see head, this is the head node at initial stage. So head previous is equal to new, and then new next. Now see, new next will point to the head node, right? So new next is equal to head, and after that head is equal to new. So it's very simple. First I have to change the chain. It's look like a chain, right? So I want to insert one block in front of this chain, so I have to make a combination, like see, the previous of the head node has the address of the new node. I have to keep the pointer to here, and then head next will have address of the head node. See, the new node next will have the address of the head node, right? So I'm making the chain, see, like this. These two lines states this, and then I am changing finally head node to newly inserted node. Okay, that's it. Now the next case is I want to insert a new node at end of the list. Look, for example, the data is 9. Here I am going to insert data 3. Okay, and address of this will be, I am going to consider 500. Okay, and so we all know that by the principle of doubly linked list, this one will have address of the previous node, right? So what is the address? 400, and the final node will be 0, and this node will have the address of the next node, which is 500, and tail has to point this, right, the last node, because tail will have the address of the last node. So let me explain. See, insert at end of the position. So I have to write the code like tail next. Initially this node is tail node, right? So tail next is equal to new, and new previous is equal to tail, and then tail is equal to new. Okay, so these three combination of codes is having a, I think it's having a magical logic. Okay, so from the diagram you can get it easily when I'm trying to insert at end of the list and beginning of the list. Okay, so that's it. You can keep this code with the creation, the main code, so it will work perfectly. That's it. If you have any doubt, you can comment in comment section, and we will see the deletion in another video. Thank you. If you have any doubts, you can mail to wingslecture.com. Thank you.